Hello, my name is ppt1 and today I'm going to talk about the impact on environment of electric cars versus gasoline cars in terms of greenhouse gas emissions. Almost all greenhouse gases such as carbon dioxide, methane, and water vapor are produced by human activities. The industrial sector and the combined commercial and residential sectors are the most significant contributors, each accounting for 30% of emissions. The transportation sector is very close behind, which is responsible for 29% of emissions, a testament to the global reliance on fossil fuels for vehicles. Agriculture is about 11%. So, with the development of science and technology, you can see people drive electric cars every day, and that there are more and more electric car companies. Unlike the gasoline cars, the energy source of electric cars is lithium batteries. When the car is out of battery, you just drive the car to a charging station to charge up the battery, just like how you do with your cell phone. Since there is no gas coming out of the tailpipe, it has zero tailpipe emissions. Life cycle emissions of electric cars versus gasoline cars. Vehicle manufacturing produces the same amount of global warming emissions for both electric and gasoline cars, while electric cars have an extra emission because of battery manufacturing. This initial emissions intensive process pay off when you look at the life cycle global warming emissions of electric cars. Cars operation accounts for most of the lifetime emissions for both gas and electric cars. But since electric vehicles run so much cleaner than gas cars, the overall emissions are much lower. As you can see from the table, for every mile driven, gasoline cars produces about 370 grams of carbon dioxide. It is only 180 for electric cars. So over their lifetime, electric cars produce about 50% less greenhouse gases emissions than gasoline cars. Another way to look at total emissions is by the break-even point. In this case, a break-even point is when an electric car makes up for the emissions produced during its manufacturing stage in its consumption stage. Essentially, how much or how long does an electric vehicle need to be driven to match the emission debit it produced in its manufacturing stage? According to the graph below, an electric car and an electric truck would need to drive 21,300 miles and 17,500 miles respectively to reach the break-even points with their gas counterparts. Considering most vehicles are driving 200,000 miles in their lifetime, that means the break-even point arrives after about 2 years of driving.